Welcome to today's class, Organic Spectroscopic Analysis. From the previous lectures, we have known that infrared spectroscopy is useful for structure analysis. In this lecture, I will talk about the infrared absorption of functional groups. Infrared absorption of organic compounds can be divided into four areas. The first infrared region is from 3700 to 2500, the prisco of centimeter. The second infrared region is from 2500 to 1900. The third infrared region is from 1900 to 1500. And the fourth infrared region is from 1500 to 600. It's also called as the fingerprint region. That is individual to each molecule. Both of OH and NH bonds occur around 3300, but they look different. Alcohol-oxygen-hydrogen bond, broad with rounded tip. Primary amine, broad with two sharp spikes. Secondary amine, broad with one sharp spike. No signal for tertiary amine. Both OH and NH bonds can form hydrogen bonding. Hydrogen bonds vary in strength and length. They cause the weakening of XH bonds. The range of strength leads to a range of absorption. However, in the structure of BHT, the steric bulk of the two tetrabutyl groups prevents two molecules of BHT from hydrogen bonding with each other, and we get a sharp peak in the infrared spectrum. OH stretch of a carboxylic acid, this OH absorbs broadly from 2500 to 3500 due to the strong hydrogen bonding. And for carbon-hydrogen stretching, bonds with more S character absorbs at a higher frequency. sp3-CH bond is just below 3000. I see to the right. sp2 carbon-hydrogen bond is just above 3000. sp-CH bond is at 3300. Stronger bonds absorbed at higher frequencies. Conjugation lowered the frequency. CH stretch in alkane is just below 3000. CH stretch in alkene is just above 3000. The CO double bond of simple ketones, aldehydes, and carboxylic acid absorbed around 1710. Usually, it's the strongest infrared signal. Carboxylic acid also have an OH group. Aldehydes have two CH signals around 2700 and 2800. The strength and the limitation of infrared are the follows. The functional group is usually indicated. The absence of a signal is definite proof that the functional group is absent. Correspondence with the new sample's infrared spectrum confirms identity of the compound. Infrared alone can't determine a structure. Some signals may be ambiguous. Let's look at a question that needs to be solved by infrared. We have an infrared spectra for an organic liquid that was found on the clothes of a criminal defendant. The criminal scene was heavily contaminated with a mixture of hydrocarbons, but there were no ketones, aldehydes, acids, or alcohols present. If the defendant's clothes contaminated with hydrocarbon, would this spectral evidence put the suspect at that crime scene? Please justify your answer with infrared functional groups information. Please solve the problem and leave your answer in the discussion section after this class. That's all for today's class. Thank you for listening.